Hi, I am Anubhav. Welcome to my talk titled Dynamic TDD Enabled Distributed Antenna Massive MIMO System. It's a joint work with Professor Chandra Murthy from Indian Institute of Science, Bangalore, and Professor Ribhu Chopra from Indian Institute of Technology, Guwahati. In this video, I will briefly explain the problem that we have investigated in this work. So we consider a distributed antenna array massive MIMO system. Here the access points or the antenna arrays are distributed over a geographical area and they jointly and coherently serve the user equipments. Now in our system model, we consider both uplink and downlink queues being present at any given time slot. Now in such a scenario, time division duplexing is a suboptimal scheme because in a TDD based system, all the access points will either operate in uplink or will operate in a downlink mode. But here we need to serve simultaneously both uplink and downlink queues. To do so, we want to enable dynamic TDD. Dynamic TDD allows us to configure the frame structure of each of these APs based on the localized traffic demands in its vicinity. So our problem is to schedule the APs in uplink or downlink mode based on the localized traffic demands so that the sum spectral efficiency is maximized. Now, one naive way to do that, so suppose there are m number of upduplex APs, we need to search over 2 to the power m such possible combinations of uplink and downlink. Now, if m is very large, exhaustive search becomes computationally prohibitive and we cannot afford that. Therefore, we need to solve this problem greedily. Before I go how we solve this problem, one thing to observe is that the APs are hub duplex, but by enabling dynamic TDD, we are able to serve the uplink and downlink queues simultaneously, and therefore the system model behaves as a virtual full duplex system. Now, in our greedy AP scheduling algorithm, we first initialize A complement greedy as the set of all AP indices. Now, in each iteration, we'll activate each AP in A complement greedy, in uplink and in downlink mode. And then we'll find the AP and the associated uplink or the downlink mode that maximally improve the sum spectral efficiency. And we'll include that AP with the uplink or downlink schedule in A greedy, and we'll update A greedy complement. And we'll keep on iterating until all APs are scheduled. To explain how dynamic TDD improves the performance of a TDD, we plot the cumulative distribution function of the sum uplink downlink spectral efficiency considering dynamic TDD and TDD in a distributed antenna array massive MIMO system. For example, we consider 128 APs. So these red curves correspond to 128 AP and dynamic TDD enabled distributed antenna array system. And these curves correspond to a TDD based DA massive MIMO system. We observe that dynamic TDD almost doubles the spectral efficiency compared to TDD. The reason being dynamic TDD will allow us to schedule the APs in uplink or in downlink based on the localized traffic demand. Whereas in TDD, all APs either operate in downlink or operate in uplink, which is a suboptimal scheme when we have heterogeneous traffic load. Thank you. If you have any question regarding this work, please feel free to mail. I'll be happy to answer. Thank you.